All right, we're just going to keep rolling through the examples. Remember, at this point, it would be a good idea to pause the video at the start of each example, try that example on your own, and then double check with the video for the solution. So as usual, we have our normal setup. We've got our target proposition over here on the rightmost column. We're going to decompose it as much as we can. So the main connective here is the disjunction. We decompose that by taking away the disjunction. We get negation P, negation Q, and we're done because there's nothing left to decompose. And of course, we know what to do here. Again, the only tricky part is making sure our eyes look at the correct column. Since this is negation P, we want to make sure to jump over here and flip these truth values, not these ones. So we know that the negation flips T to F, T to F, F to T, F to T. And similarly, we know that looking over from Q to not Q, we go T, F, F, T, T, F, F, T. Now we've got everything we need to fill in our rightmost column. We know that the disjunction is false only when both of the disjuncts are false. So that's going to be here we've got an F. Here we've got one of the disjuncts is true, so we're going to have a T for the disjunction. And again, in both of these cases, at least one of the disjuncts is true, so we're going to have true and true. Again, this is intuitively like someone saying either it won't rain or it won't snow, which is going to be true in all cases, except when it both rains and snows. Here we have yet another example where the main connective is a disjunction. So by taking away the disjunction, we get negation Q and P, but we already have P filled out over here, so we're ready to go. We only need one column in the middle here. Notice that how many columns you need in between is totally dependent on the particular proposition. So if you're writing these out by hand, leave yourself some extra columns, and it's okay if you've got some blank ones. You just don't want to run out of room if you don't know how many columns you're going to need. Of course, here we're going to flip the truth values for this column. We're going to go from T to F, F to T, T to F, F to T. Now we're ready to go. We know that a disjunction is false only when both disjuncts are false. So here, at least one of the disjuncts is true, so we're going to have a T. Here, both disjuncts are true, so we're going to have a T. Here we've got both disjuncts false, so we're going to have a false. And here we've got at least one disjunct true, so we're going to have a T. Moving into a slightly more complex example, here we've got P and Q, or P or Q. This is like if someone said, either it'll rain and it'll snow, or it'll rain or it'll snow. Now that's a fairly artificial sentence. You won't hear anyone speaking like that in everyday life, but again, symbolic logic is designed to test complex mathematical and philosophical claims, in which case a statement like this might be made. So as usual, we're going to have our target sentence over here, and we're going to decompose it by identifying the main connective. That's this disjunction here. It's the one that applies to the whole formula. So we'll take that away, and what do we get? We get P and Q, and we get P or Q. Now, if we decomposed each of these, we'd end up with P and Q. We've already got that, so we're done decomposing. Now we can just apply the truth tables for conjunction in this case. So we know that conjunction is true only when both of the conjuncts are true. So we've got true, true here. We're going to have a true there. And we know that at least one of the conjuncts is false in all of these other cases. So we're going to get F's all the way down. By contrast, the disjunction is false only when both of the disjuncts are false. So we're going to have T's all the way across, except for this lowest one here. Finally, we're ready to put these two together and apply the truth table for disjunction to these two columns. And we know again that the disjunct is false only when both of the disjuncts are false. That happens only here. So we're going to have trues all the way down except false here. So again, this truth table tells you that if someone were to utter to you the odd sentence, look, either it's going to rain and snow, or it's going to rain or snow, you would know how the world needs to be in order for that statement to be true. And it would be false only in case it didn't rain and it did not snow. Let's ramp up the complexity for our final example. Some important things to point out here. Notice that this is not more complex in the sense that it has more connectives, but rather in the sense that it has more unique primitives. So we're dealing with 3 unique primitives here, P, Q, and R. And this is something you'll want to memorize. You'll want to memorize the setup for the truth table for up to 3 primitives. We won't go beyond that. So now we're going to need 8 rows instead of 4 to exhaust all of the combinations of truth values for P, Q, and R. And the easy way to remember this is to remember the pattern for each column. In the leftmost column, you'll have 4 truths and then 4 falses in a row. For the middle column, you'll just alternate pairwise. True, true, false, false, true, true, false, false. And then in the rightmost column, you'll just alternate line by line. TF, 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 TF. And if you just follow that algorithm, you will have exhausted all the combinations without having to think about it. Again, these parts of logic are much like training yourself to be like a computer and execute effective procedures rather than think too much. This is giving you a way that you don't have to think and you can still evaluate these forms of proposition. So as usual, once we've done that, we get our target proposition over here on the right-hand side. We identify the main connective. It's going to be this arrow in this case. We take away the arrow, and what do we get? We get P, which we've already got over here, and we get Q or R, which we need a new column for. Decompose that, and we get Q and R. So we're already done decomposing. Now we can apply the truth table for disjunction to Q and R. We know that disjunction is false only when both of the disjuncts are false. So we're going to get a true when both disjuncts are true. Here we have at least one disjunct true, so we're going to get a true. Same thing here. Both false in this case. And we get down the line, and then we come to this where they're both false again, so we get a false. Now, this is our first time filling out a truth table in this video for conditional. So here's a little tip for conditional. If you look at the truth table for conditional, you'll notice that whenever the consequent is true, the conditional as a whole is true. So look at the consequent first. If it's true, you know you can write a T. Only if the consequent is false do you need to then check the truth value of the antecedent. So here we have the consequent is true. We get true for the conditional. Again, the consequent is true, so we can write true for the conditional and not even look at the antecedent. Here we have a false consequent. Now, that doesn't necessarily mean the conditional is going to be false, but if there's a false consequent, we need to look at the truth value of the antecedent because we know that a conditional is false only when it takes us from a true antecedent to a false consequent. So we need to look all the way over here at the antecedent. It's true, and it's taking us to a false consequent. So we're going to have a false here. All right, now the consequent's true, so we can jump right over to true for the conditional. Same here and same here. Here we get another false consequent. So it's important to look over to the antecedent. And notice the antecedent in this case is false. So even though the consequent is false here, since we're going from false to false, according to our truth table for conditional, we still get a true conditional. So in this case, we have false only on this row. Again, mastering truth tables consists in practicing enough that you feel like a computer executing these efficient procedures. There's an algorithm. You just fill out the table according to the rules. Don't overthink it. The point is that the truth value of these complex statements boils down to how things stand with the simple statements, P, Q, and R. And this could apply theoretically to propositions with infinite complexity. So from a simple set of basic rules, we can systematically determine the way that the truth value of the whole depends only on the truth value of the parts. And that is what we study in symbolic logic.